Hi learners, welcome to our today's lesson on pressure. In the last lesson, we discussed questions in pressure in liquids. But today we are going to discuss to solve some problems involving transmission of pressure in liquid. And here I have some questions that I've prepared. Question 1, the figure below shows a simple hydraulic lift used to compress bale. The cross-section area A and B are 0.02 meters squared and 0.30 meters squared respectively. This is the diagram. We have A and B. We have bale. We have force 1. We have the area. Then we have another area. This liquid inside this hydraulic lift is oil. The questions are: determine the pressure exerted on the smaller piston. Now, solution. We had said that pressure, that is pressure is equals to force over area. Remember, we have been given now smaller piston. This is small. From the look of this diagram, this is small and this is larger. So this one represents a small piston, then this one is larger piston. So when I want to calculate pressure exerting smaller piston, then from the formula, I'm supposed to have the force, which is this F1, and area, which is A1. So this one simply means I'm just going to take F1 then over A1. I have F1, it is 180 Newton, then A1 is 0.002, that is meters squared. So now I simplify this using a calculator. It gives me, that is 180 divided by 0.002, that is 90,000 Newton per meter squared. 90,000. This is 90,000 per meter squared. Then part B, pressure exerted on B by the oil. B, pressure exerted on this one. Now, when you are discussing this hydraulic lift, we said that pressure, by Pascal's principle, pressure transmitted in liquid is equally transmitted to all other parts of that unenclosed system. So if I use this as an example, if I've calculated here pressure and it's being transmitted from here, it will be equally be transmitted to this one, to the bale. So meaning that pressure in, that is pressure in limb A is equal to pressure in limb B. Pressure at A is just the same as pressure at B. This is by Pascal's principle. By Pascal's principle. Meaning that pressure exerted on B, pressure exerted on B is equal to 90,000 Newton per meter squared. Then C, we are being asked to determine the force produced on B to compress the load. Remember, we have the pressure, we have the area. And by pressure, we have said that pressure is equal to force then over area. We have been asked to determine force, meaning that my force is given by pressure, then times area. So that is B, and we have said that pressure here it is 90,000, then we have the area. So we just substitute in our formula, meaning that we have 90,000, then times area, which is 0.3. 90 times 0.3. This is 27,000. Force Newton. So this is the working of part C of the first question. So we are going now to move to question 2. Question 2. In question 2, it is written, in a hydraulic brake system, an effort of 20 Newton is applied on the brake pedal connected to a piston of area 0.05 meters squared. This generated a stopping force of 500 Newton. Calculate A, the pressure in the master cylinder, then area of the slave piston. Now, we discussed how a hydraulic brake system works. And remember, a pedal is always connected to a master cylinder, meaning that this effort, the brake pedal is connected to master cylinder. The area is just the same of that of the master cylinder. That force is equal transmitted to that master cylinder. Now, when you want to simplify it, that is A, question 2, A. So, pressure in the master cylinder. Pressure in the master cylinder is equal to force then over area. As I have said, master cylinder is connected to the brake pedal. The area of master cylinder and brake pedal is just the same. Then force, we have said this force, it is just the same. When I want to calculate that pressure, I just substitute in the values. So I have 20 force divided by area, which is 0.005. 0.005. So we have 20 divided by 0.005. We have 4,000. So this gives me 4,000 Newton per meter squared. That is part A. Then for part B, the area of the slave cylinder. As I have said, this pressure transmitted from the master cylinder, it will be equally be transmitted to all other parts of that brake system, meaning that the slave cylinder, it will also receive the same pressure. So pressure on the slave piston, so B, we are being asked to calculate the area, but we know that pressure on the slave piston is equal to force over the area of slave piston. This implies that area of slave piston is equal to pressure then times not that one, so is not that way. So when we cross multiply, it means that my area is given by force, then over pressure. Force over pressure. Force over pressure. And I've said pressure is the same. We have calculated here. So P1 and P2, it is just the same. So pressure is equal. This is by Pascal's principle. So this implies that if I want to get that area of piston, slave piston, is equals to force, and our force is here, 5,000 divided by our pressure, which is 4,000. It is 4,000. So we take, that is 500 divided by 4,000. It is giving me 0.125. This is area, so meters squared. Meters squared. This is the working of question 2. We have done part A and part B. So I would like to give you an assignment that you may try to understand, or you may work it out using this principle or examples that I have given. So assignment, so these are the two questions that I would like you to attempt. The first one, the figure below shows a hydraulic lift. The cross-section area of a smaller piston A is 5 centimeters squared, and that of a larger piston is 80 centimeters squared. Given that the force of 100 is applied on a smaller piston, calculate the pressure on the smaller piston, B, the pressure on the larger piston, C, the force on the larger piston, and this is the diagram. Then question 2, the figure below shows part of a hydraulic machine used to lift load. This is the diagram. We have larger piston, we have smaller piston. Then here, A, given that A1 is equals to 0.06 meters squared, A2 is 0.5 meters squared, and F1 is 120 Newton. Calculate the pressure in the hydraulic fluid. Then 2, calculate force that is used to lift the load. So kindly attempt this question when you are at home. This marks the end of our today's lesson. God bless you and bye-bye.